All right, welcome to today's class. In our last class, we talked about sets, the definition of sets, and the things that you must know when dealing on sets. So if you missed our last class, kindly check the description of this video and you will see a link to our tutorial video on sets. In this class, we are going to be considering the types of sets. There are various types of sets. The first type of set here is empty set. What is an empty set? An empty set is a set containing no element. It is written as a pair of curly brackets with nothing inside, or phi. All right, so let's take an example. If A is equal to this, then A is an empty set. Why? Because there is no element inside the curly bracket. So we only have the curly bracket here. So A is an empty set. Or if B is equal to phi, if B is equal to phi, therefore B is an empty set. Now let's look at the definition of an empty set again. An empty set is a set containing no element. It is written as a pair of curly brackets. So this is a pair of curly brackets with nothing inside. So there is no element inside this curly bracket, or phi. So A is equal to a pair of curly brackets with no element. So A is an empty set. And then B is equal to phi. Therefore, B is an empty set. The second type of set we have here is a singleton. So what is a singleton? A singleton is a set that contains only one element. A singleton is a set that contains only one element. So let's take an example. If A is equal to 5, therefore A is a singleton because the only element in set A is 5. But then take note of this. If B is equal to a curly bracket and phi inside of the curly bracket, B is a singleton. Now, from the concept of empty set is defined as a set that has no element inside, or phi. There is no element in A, so therefore A is an empty set. B is equal to phi, therefore B is an empty set. But when phi is enclosed by curly brackets, therefore it becomes a singleton. B is a singleton. So learn how to differentiate between an empty set and a singleton. An empty set has no element inside, or an empty set is phi alone. But when phi is inside a curly bracket, therefore it becomes a singleton. All right, so let's consider the third type of set. We have the finite set. A finite set is a set that contains a limited number of elements. A finite set is a set that contains a limited number of elements. So let's take an example. Let's say set A is a set of natural numbers. A is a set of natural numbers less than 10. So A is a set of natural numbers less than 10. So let's represent this. So A is equal to, you open your bracket, natural numbers less than 10. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the natural numbers less than 10. So therefore, A is a finite set because the numbers are limited. It cannot be more than 10 as stated. A is a set of natural numbers less than 10. So you can see that set A is limited, so it ends at 10. So you start from 1, natural numbers 1 to 10. So if it is more than 10, then it is not set A. So that's what makes it a finite set, because a finite set is a set that contains a limited number of elements. Take note of this. It is a limited number of elements. All right, so the next type of set here is an infinite set. So what's an infinite set? An infinite set is a set that is contrary to the finite set. Its elements are unlimited. Remember, the elements of a finite set are limited, but the elements of an infinite set, they are not limited. So let's take an example. So let's say A is a set of natural numbers. So A is a set of natural numbers. So let's represent this. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it goes on and on. So it shows that they are unlimited. It is an unlimited set because we are told that A is a set of natural numbers. They didn't give us a limit. So the element of A can be 100, can be 200, can be 300, can be 50. So that's what makes it an infinite set. But then in finite sets, we are told that finite set is a set that contains a limited number of elements. So there is an end to it. Check the example. A is a set of natural numbers less than 10. So the limit here is 10. So that's what makes it a finite set. But then an infinite set has no limit. So it can be 100, it can be 200, it can be 300, whatever. But you need to know that an infinite set has no limit, but a finite set has limit. All right, so the next type of set here is an equal set. So what's an equal set? Two sets are said to be equal if they both contain the same element. Two sets are said to be equal if they both contain the same element. So let's take an example. So let's say A is equal to 1, 2, 3. And then B is equal to 2, 3, and 1. If you look at set A has 1 as its element. Now look at set B. Set B also has 1 as its element. Set A has 2 as its element. Set B also has 2 as its element. Set A has 3 as its element. And set B has 3 as its element. So therefore, set A is equal to set B. All right, so let's consider the next one, cardinality of set. The size or cardinality of a set is the number of elements the set contains. Let's take an example. If set A is equal to 1, 5, and 4, what is the cardinality of A? The cardinality of A is written as this: n open bracket A and then close bracket, or A. So the cardinality of A is equal to 3. Why is it 3? Because set A has 3 different elements. 1 is an element of A, 5 is also an element of A, and 4 is an element of A. So let's count 1, 2, 3. So that's what makes it 3. So the cardinality or size of a set is the number of elements it contains. All right, so let's consider the next. We have equivalent sets. What are equivalent sets? Equivalent sets have different elements but have the same number of elements. Equivalent sets have different elements but have the same number of elements. So let's take an example. So if set F is equal to 1, 2, 3, 4, and 5, and then set H is equal to H, E, A, R, and T. Now let's find the cardinality of both sets. For F, the cardinality of set F is equal to 5 because it has 5 elements. Let's count. 1, 2, 3, 4, 5. So it has 5 elements. Now let's find the cardinality of set H. The cardinality of H is equal to 5. Why? Because it has 5 different elements. Let's count. 1, 2, 3, 4, and 5. So therefore, since set F and set H have equal cardinalities, they are equivalent. All right, let's consider the next one, which is subset. Set A is a subset of B if every element in A is also an element in B. Let's take an example. So let's say set B is equal to 1, 2, 3, 4, and 5. And then set A is equal to 1, 3, and 5. Now look at set A. Set A has 1 as its element. 1 is also in set B. set A has 3 as its element. 3 is also found in set B. Set A has 5 as its element. 5 is also found in set B. So since all the elements of A are found in set B, therefore A is a subset of B. So this sign is used to show that a set is a subset of another set. So therefore A is a subset of B. All right, so let's consider the next one. The next one here is superset. Set A is a superset of B if every element in B is in set A. Let's take an example. If set A is equal to 1, 2, 3, 4, and 5. And then set B is equal to 1, 2, and 4. Now, if you look at set B, you will see that all the elements in set B are found in set A. So therefore, set A is a superscript, is a superset rather, of set B. So since all the elements in set B are found in set A, therefore set A is a superset of set B. All right, so let's consider the next one. We have power set. What is a power set? A power set is the set of all possible subsets of a given set, including the empty set and the set itself. Let's take an example. So if set A is equal to 1, 5, and 4, the power set of A is written as this: P open bracket A close bracket. So the power set of A is equal to 2 raised to power n. So what is n? N is the number of elements. Number of elements. So n is the number of elements in set A. So therefore, the power set of A is equal to 2 raised to power. Now let's count the number of elements in set A. We have 1, 2, 3. So it is equal to 2 raised to power 3. So power set of A is equal to 2 raised to power 3 is 8. So how do we write the power set? We have, you first of all open a big curly bracket, and then you gradually start with an empty set. You start with an empty set. Remember, the power set of A is equal to 8, so it must be 8. So you start with an empty set, and then comma. What follows is a singleton. So the first element in set A is 1. So you close bracket. So what's the second element in set A? Remember, set A is equal to 1, 5, and 4. So we are going to write all these elements individually. So we've written 1. The next one is 5. And then comma. The next element in set A is 4. So since we are done with all the elements in set A, we are going to write them in 2s. So we'll start with 1 and 5. So you open your bracket, you write 1, comma, 5. And then comma, you open another bracket, you write 1, comma, 4. And then you open another bracket, you write 5, comma, 4. So we've written them individually and we've written them in 2s. First of all, you start with an empty set. You move on to individual set. And then you write in 2s. So when you are done writing in 2s, the next one is to write in 3s. So we have the element in set A are 1, 5, and 4. Close the bracket. So since we've closed the bracket, now let's now count. Remember, the power set of A is equal to 8. The power set of A is equal to 8. So let's count if it's up to 8. We have 1, 2, 3, 4, 5, 6, 7, and then 8. So this is correct. So this is how you write power set. Whenever you are given a question to find the power set of any set, the first thing to do is to calculate for the power set, which is P, open bracket, the set itself, equal to 2 raised to power n. The n is the number of elements. The n is the number of elements. So after calculating for the power set, you can now arrange it this way. You can now arrange it this way. First of all, you start with an empty set, and then you begin to write the elements of that set individually. And when you are done, you move on to 2s. You write them in 2s. And when you are done writing in 2s, you write in 3s. All right, let's consider the next one. We have universal set. A universal set is the set that has all the elements that are being considered. A universal set is a set that has all the elements that are being considered. Let's take an example. Let's say set A is equal to 3, 4, and 5. And then set B is equal to 1 and 5. And then the universal set U is equal to 1, 2, 3, 4, 5, 6. Now let's check the definition of universal set again. A universal set is the set that has all the elements that are being considered. U is universal set, And the elements in the universal set are 1, 2, 3, 4, 5, and 6. Now, let's compare the universal set to set B. In set B, we have 1 and 5. 1 and 5 are found in the universal set. Let's also compare the universal set to set A. In set A, we have 3, 4, and 5. 3, 4, and 5 are also found in the universal set. So the reason why it is called universal set is because it contains all the elements that are being considered. Set A elements are found in the universal set. Set B elements are also in the universal set. So that's what makes it a universal set.